Hello students, I am Tulika Banerjee. Today I bring you the next learning episode in BSc Forensic Science on an important unit of the paper titled Fingerprints, that is Chemical Method for Detection of Latent Fingerprints Part 1, Silver Nitrate and Iodine Fuming. In this lecture, you will be studying how silver nitrate reagent detects latent fingerprints on a wide range of porous items, the methodology and mechanism by which silver nitrate develops fingerprints, the merits and demerits of silver nitrate technique for visualizing latent prints. In addition to it, you will be studying the significance of the iodine method, a vapor phase technique of fingerprint detection, the methodology of iodine fuming and the mechanism of fingerprints detection by iodine technique, the role of fixing reagents to prevent the fading out of iodine developed prints, a critical assessment of iodine method for developing latent prints will also be explained in this lecture. Let us start our today's lecture with a brief look at what we will be learning in the modules today. Introduction to silver nitrate and iodine fuming technique, mechanism of silver nitrate technique, methodology of silver nitrate technique, assessment of silver nitrate method, methodology of iodine fuming method, post-treatment of developed fingerprints by iodine fuming, and assessment of iodine method. And lastly, we will wind up this module with a conclusion. So, let us start our lecture with the introduction to silver nitrate and iodine fuming technique. First of all, we will be explaining about the silver nitrate technique. Silver nitrate technique is one of the oldest methods of detecting latent fingerprints on porous items like paper, cardboard and wood. The method is based on the reaction of silver ions with the chloride content of sweat residue. The reaction product, that is silver chloride, is relatively unstable and when exposed to ultraviolet radiation or sunlight decomposes it to finely divided silver, visualizing the ridges as dark hue, usually black or brown in color. It is a destructive technique. The ninhydrin method of developing fingerprints on porous articles was standardized later. However, this method proved more advantageous and subsequently replaced the silver nitrate procedure. A sample fingerprint developed by silver nitrate technique has been shown on your screen. The next technique is the iodine fuming method. The iodine fuming technique for visualizing latent finger marks have been used for almost a century. Iodine is a crystalline solid which upon heating sublimes into violet vapors. The vapors are absorbed by the sweat deposition of the latent imprint, thereby revealing the ridge pattern. Initially, it was believed that iodine can be added chemically and reversibly to double bonds of the unsaturated fatty acids present in the fingerprint residue. However, it was later suggested that the mechanism of the reaction involved physical absorption of iodine on the fatty acid content. The iodine fatty acid interaction imparts a yellowish brown color to the ridge pattern. Iodine fuming is a simple procedure of developing latent fingerprints. A sample fingerprint developed by iodine fuming method has been shown on your screen. Next students, we will be discussing over here the mechanism of silver nitrate technique, because in this lecture we have two chemical techniques, that is, one is the silver nitrate and the other one is the iodine fuming method. So, first we are taking up the mechanism of silver nitrate technique. Detection of the latent fingerprints by silver nitrate is based on the premise that the said reagent undergoes chemical interaction with the chloride content of sweat residue. This reaction produces a precipitate of light sensitive silver chloride. When white colored insoluble silver chloride is exposed to either sunlight or UV radiation, it gets reduced to metallic silver. The reaction scheme has been depicted on your screen. The finely divided black or brown colored metallic silver adheres to the ridges and visualizes the print. Next, we have the methodology of silver nitrate technique. The silver nitrate reagent develops fingerprints on porous surfaces such as papers of different varieties, cardboard and raw or unpolished wood. The reagent is dissolved in distilled water or in a mixture of distilled water and methanol. Tap water is not used since it invariably contains chloride ions which transform silver nitrate to silver chloride. The concentration of silver nitrate in test solution may vary from 1 to 10%. However, a 3% solution by weight by volume is considered to be the best choice. The latent fingerprint bearing item is treated with the test solution either by dipping or by spraying. The treated item is then allowed to dry under natural conditions for 5 to 10 minutes. Thereafter, it is exposed to either sunlight or light from an ultraviolet source or lamp until the best contrast between the developed fingerprints and the background surface is obtained. A sample fingerprint developed by silver nitrate reagent is shown here. After the fingerprints develop, the article should once again be washed with water so as to remove excess of silver nitrate. Otherwise, the silver ions adhering to the surface are slowly transformed to metallic silver. As a result, the entire surface gets stained and consequently the contrast between the developed print and the background is substantially reduced. Nevertheless, the staining of the background cannot be completely avoided. Since the method is applicable to porous items, some silver ions inevitably seep into the capillaries of the substrate and eventually impart a dark color to the background. To avoid this problem, it is recommended that as part of post-development procedure, the item should be first washed with water and then area outside the periphery of fingerprint be treated with a stopping solution. The latter delays the darkening of the background. The most commonly used stopping solution is that of mercuric nitrate, 3% weight by volume in distilled water. As the silver ions absorbed into the body of substrate are transformed into metallic silver, the mercuric nitrate reverses the reaction. That is, the metallic silver which would have stained the background is reconverted to soluble silver nitrate which is subsequently drained off. The reaction involved in this procedure has been depicted over on your screen. Next, moving on to the assessment of silver nitrate method. As with other chemical methods of fingerprint detection, the silver nitrate technique has both advantages and disadvantages. The major advantage of this method is that the chloride ions in latent fingerprints are non-volatile and therefore fingerprints which are almost 1 week old may be developed by silver nitrate reagent. However, after 7 to 10 days, the chloride ions of sweat residue tend to diffuse into the body of the substrate and the prints developed by silver nitrate are not of optimum quality. The ninhydrin and iodine fuming methods of fingerprint detection do not interfere with the silver nitrate technique. Thus, this method may be used as a final step to reveal fingerprints when the other conventional methods do not yield results. In fact, if the fingerprints developed by ninhydrin on a particular surface are weak and faint, the item may be post-treated with silver nitrate to give a better contrast. The main demerit of the silver nitrate method is that although the developed prints are of intense color, the background is stained and over a period of time the contrast is lowered. The staining may be delayed by either post-treating the background area with a stopping solution or by preserving the developed prints in a dark chamber. Silver nitrate is a costly and a toxic chemical. On coming in contact with the skin, it produces a black mark which persists for several days. Now, dear students, we will be discussing here in this lecture the methodology of iodine fuming method. Latent fingerprints may be developed by iodine fuming technique by one of the following experimental procedures. First, here is the fuming gun method. An iodine fuming gun is made of either glass or plastic. The butt end of the gun contains a dehydrating agent, usually calcium chloride. There is also a mouthpiece for blowing air at this end. Near the nozzle end of the gun, about 0.5 grams of iodine crystals are placed. Air is blown through the mouthpiece and the gun nozzle is moved above the surface impinged with the latent prints. The optimum distance between the gun and the surface is about 2 centimeters. As soon as the latent fingerprints begin to appear, the iodine fumes are concentrated over the imprinted area. The prints so developed are photographed immediately. The next method we have in iodine fuming only is the fuming cabinet method. A china dish containing about 1 gram of iodine crystals is placed in a fuming cabinet. The object bearing the latent prints is suspended from the roof of the cabinet. Iodine crystals are gently heated to about 50 degrees centigrade using a heating block. After a few minutes, latent fingerprints begin to appear. The object is exposed to the fumes till maximum contrast has been achieved between the prints and the background. The developed fingerprints are immediately photographed. The third method over here is the powder dusting method. Iodine crystals are pulverized into a fine powder. The powder is spread out over the surface bearing the latent fingerprints by a camel hair brush. The excess powder is then blown off. This method does not require any equipment and is therefore both simple and cost effective. However, it exposes the user to the toxic fumes of iodine. As a result, this method is now obsolete. Next, we will be discussing over here about the post-treatment of developed fingerprints by iodine fuming method. Fingerprints developed by iodine are not permanent in nature. These tend to fade out on standing. In presence of air, the fading of prints is accelerated. For this reason, the iodine developed prints have to be photographed immediately. Nevertheless, it is possible to fix the prints by using iodine in conjunction with other chemical reagents. Iodine is known to react with starch, giving a stable deep blue complex. Thus, post-treatment of iodine developed fingerprints with starch solution gives long-lasting blue impressions. The fading problem may also be avoided by pressing a silver foil onto the iodine developed finger marks. The interaction of iodine absorbed on the fingerprint residue with silver produces yellow colored silver iodide. The latter, on exposure to light, decomposes into finely divided silver, revealing the rich pattern as a stable black deposition. Iodine Exposed fingerprints may be fixed by post-treatment with a solution of N-N-N-N-tetramethyl 4,4-diamino diphenyl methane in 1,2,2-trichloro-trifluoromethane. The color of the prints change from brown to green blue. The figure shows an iodine developed fingerprint, half of which was treated with N-N-N-N-tetramethyl 4,4-diamino diphenyl methane reagent. The treated part is blue in color while the untreated part is brown in color. Nevertheless, the quality and clarity of post-treated fingerprints are not affected. Iodine developed fingerprints on thermal paper may also be fixed by spraying with a hexane solution of N-N-N-N-tetramethyl 4,4-diamino thiobenzophenone as has been shown on the figure, or phenothiazine as has been shown on your screen. With former, the color of developed prints changes to blue, while with the latter, reddish impressions are obtained. The most common reagent for fixing iodine developed prints is 7,8-benzoflavone, the structure of which has been shown on your screen. A mixture of 2 ml of 10% 7,8-benzoflavone solution in dichloromethane and 100 ml of 0.1% iodine solution in cyclohexane is used for this purpose. Iodine in combination with 7,8-benzoflavone reagent may be used for developing old latent fingerprints on porous surface such as bond paper, newsprints and facial tissue paper. The composition is non-destructive and the documents remain unaltered. Sublimable or low boiling organic reagents may also be made to interact with and fix iodine absorbed on the latent fingerprints used in vapor state. For example, iodine interacts with alpha-naphthylamine to form a red colored charge transfer complex. Although free iodine does not possess a natural dipole moment, yet in concert with an aromatic system, it requires or acquires an induced dipole. The combination of electron-rich aromatic compounds and dipolar iodine results in charge transfer complexation as has been shown on your screen. The charge transfer complex is non-volatile in nature and hence it does not evaporate from the frictional ridges. As a result, the developed prints do not fade out with passage of time. Representative fingerprints developed on different items are depicted in this figure on your screen. Next is the assessment of iodine method. The iodine method for detecting latent fingerprints has the following advantages. The procedure is very simple to use and requires only a meager degree of skill and experience. With conventional chemical developing reagents, the latent fingerprints on the surface in question are first visually searched and then the relevant spray or powder formulation is applied. However, while using the iodine method, there is no need to first scan the surface. Iodine vapors on their own get preferentially absorbed on the fingerprint residue, revealing the ridges. A number of chemical fingerprint development methods such as ninhydrin, cyanoacrylate and silver nitrate requires instrumental detection techniques such as laser and neutron activation analysis and therefore cannot be used for on-the-scene investigations. The object bearing the latent finger marks has to be carried to the fingerprint laboratory if any of these methods is desired to be used. However, iodine in conjunction with 7,8-benzoflavone may be used for detection of fingerprints at the scene of crime. Iodine fuming is a sensitive method for developing latent fingerprints on porous surface, such as paper and paper products. The other reliable method for porous surface is the ninhydrin technique. However, good results are obtained by ninhydrin only after the developed fingerprints are treated with metal salts, following by laser action or laser examination. No such costly equipment is required with iodine. Iodine fuming develops both fresh and relatively old prints. Iodine fuming is one of the techniques which can develop fingerprints in human skin. The area of skin suspected to be impinged with latent print is treated with iodine vapors. Once the impression appears, these are pressed onto a silver plate. Exposure of the plate to light reveals permanent finger marks. If in a particular casework investigation, iodine method fails to detect fingerprints on crime scene evidence, other techniques like ninhydrin method may still be tried out. Iodine method suffers from few shortcomings. They are that the iodine developed fingerprints fade out in a short time. Hence, these have to be fixed using a suitable reagent. Yet, it is pertinent to state here that other fingerprint detecting techniques such as powder dusting, ninhydrin spraying and cyanoacrylate fuming do give good results only after post-treatment operations. Iodine is toxic and poses occupational hazards to the user. Nevertheless, by observing some simple safety precautions, this problem may be eliminated. Let us come to the conclusion of this lecture. Silver nitrate method of developing fingerprints is a relatively simple and easy technique. It does not require a sophisticated instrument or costly equipment. However, it does not have broad-based applications and works on only porous surfaces. Yet, for porous items also, ninhydrin has proved to be a better reagent. Therefore, the silver nitrate method is considered obsolete in casework investigations. The ninhydrin and iodine fuming methods of fingerprint detection do not interfere with the silver nitrate technique. Thus, this method may be used as a final step to reveal fingerprints when the other conventional methods do not yield results. It is a destructive technique. Iodine method has traditionally been very popular for processing imprints on porous surfaces. The method relies on the physical absorption of iodine vapors on the fatty acid content of fingerprint residue. Several post-treatment options are available to enhance the stability of developed prints. In case prints fail to develop by iodine method, other methods of fingerprint detection may still be tried out. The reverse is not true. With all these information here, we come to the end of today's lecture. Do keep in mind what we have discussed today. I'll be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Thank you for your time today. I will see you in the next lecture. Have a great day.